I heard that you're approaching infinity, that you moved to third period and you're new here. I heard that you have no limit. Guess you didn't pay attention in math. New kid, why are you so shy? Ain't like you to not talk or pass the quiz. I hate to be rude and to not show up to tutoring, but I couldn't make it, I couldn't bother. I thought you'd see my face and that you'd be reminded that for me it isn't hope. Never mind, I'll find another limit like you. I wish nothing but infinity for you too. Don't fail me, I beg. Oh, I remember you said sometimes the limit is 3, but sometimes it's undefined. Sometimes the limit is 3, but sometimes it's undefined. You know how the class flies only. Yesterday the limit was a lie. We were born and raised in a summer haze, bound by the surprise of our lazy days. I hate to be rude and to not show up to tutoring, but I couldn't make it, I couldn't bother. I thought you'd see my face and that you'd be reminded that for me there isn't hope. Never mind, I'll find another limit like you. And I wish nothing but infinity for you too. Don't fail me, I beg. Oh, I remember you said sometimes the limit is 3, but sometimes it's undefined. Sometimes the limit is 3, but sometimes it's undefined. The limit exists, no questions are asked. The test that we failed were the graphs we misread. Who would have known how difficult continuity would be? Never mind, I'll find another limit like you. And I wish nothing but infinity for you too. Don't fail me, I beg. Oh, I remember you said sometimes the limit is 3, but sometimes it's undefined. Sometimes the limit is 3, but sometimes it's undefined. Yeah.
Shut up! Shut up!
Are we ready?
Yeah.
Alright. Take out a piece of paper and pencil.
Do we have to?
Yes, Sanjay. You have to.
Can we write in pen, Mr. Mac?
No. This is math. Take out a pencil.
Evil Mac.
Alright, class. Today we're going to be learning about triangles. Now, I shouldn't even have to go over special right triangles, because you learned that in geometry.
What are special right triangles?
What's geometry?
I don't get geometry.
I had a really bad teacher.
Sanjay, Daniel, be quiet.
Evil Mac!
Yes, Eunice.
So, I made this special right triangle chart last night for fun. So instead of using the smiley face I usually did, I used the most beautiful man on earth. What directions?
Take a seat, Eunice. Take a seat. That's Eunice.
You could get Roberto to pick it up. He's Mexican.
Evil Eunice!
For those of you who still need review on special right triangles, you can find Eunice's little diagram in the trash.
Evil Mag!
Now, moving on. Now, a quick review. Of course, you can use trigonometry to find any missing sides. As you know, cosine is adjacent over hypotenuse, sine is opposite over hypotenuse, and this year tangent is going to be sine over cosine. And that's about all the time I'm going to waste with you people who didn't pay attention in the beginning of the year.
Evil Mac!
Now, we'll move on to law of cosine. Now, in order to start doing this, the first thing you're going to do is, because of the fact that law of cosine is used when you do not have right triangles already, we're going to go ahead and assume that this triangle right here is an oblique triangle. So in order to use law of cosine, you need to assume that this angle right here is given, and we'll just call this angle A. And now we have to have at least two sides that are given. So we'll call this side C, and we'll call this one side B. And it is important that we use two sides that have the angle in between. Alright, and then we'll just say that this one over here is, of course, side A. Now, what we need to do is go ahead and bisect this oblique triangle so that we can go ahead.
Oh, I dissected a cat in anatomy!
Bisect, not dissect.
Oh.
So now, once we do this, we can now have 90-degree angles. So we can now use trigonometry. So the goal of all of this is to find what the measure of side A is. So the first thing we need to know is what the lengths of these two sides are now. Since we have bisected this, now we have C that has been broken up. And let's go ahead and call this side right here side D, and this one over here E. So now we need to know what exactly are their lengths. Well, to find D, what we can do is, of course, using trigonometry, we see that this is the adjacent side and this is the hypotenuse. So we have cosine of A is equals your adjacent, which is D, over your hypotenuse, which is B. Now, if we rearrange that to find the exact length of D, we have D is equal to B cosine A. Now, we need to find the length of E. So now, E, as you can see, is C minus whatever D is. So now we have E is equal to C minus, and as we know, D is B cosine A. So we do B cosine A. So now the next thing we need to know is what is the height of this triangle. And so we'll just call this side M. Okay? And so now how do you find M? Well, if you have this angle and it's your opposite, now you can use sine of angle A. So we'll move it over here. Sine of A is equal to your opposite M over your hypotenuse B. If we rearrange this, we'll find that M is equal to sine A times B. Alright, so now since we have this side and we want to find A now, what can we use?
I don't know.
Patrick, what can we use now that we have this and now we now need to use this find the hypotenuse? What do we do?
The Pythagorean theorem, of course. This lesson is so arbitrary.
Okay. So now we can do A squared is equal to M squared plus E squared.
I thought the Pythagorean theorem was A squared plus B squared equals C squared.
It is. But these are just variables, Sanjay. Now, back to this. So now all you have to simply do is plug in your values that you just found. So your A squared is equal to B sine A squared plus C minus B cosine A squared. Okay? So, if we distribute the exponent, we find that this is B squared sine A squared plus, using the box method. I'm not going to go over the box method because that's something you should have learned last year. So after you do that,
Evil man.
you get C squared minus 2CB cosine A plus B squared cosine A. And this, of course, is also squared. Alright, so now if we rearrange this, we can see that B squared sine A squared plus B squared cosine squared A minus 2CB cosine A. Now, look at this. We can obviously take out the B squared. So we'll have B squared is equal to sine squared A plus cosine squared A minus 2CB cosine. Oh, I forgot to bring down the C squared. So we will put that in here. Plus C squared minus your 2CB. So now, since you now know your identities, something should be sticking out, right? So sine squared A, what is sine squared A plus cosine squared A equal to?
It's obviously 1.
Okay. Thank you, Patrick. So B squared times 1 plus C squared, brought it down from over here, minus 2CB cosine A. Cosine A. So now this means that this is B squared plus C squared minus 2CB cosine A is equal to A squared. And this now is your law of cosine.
Why do we need to know that?
Alright, so now that we finished law of cosine, we can go on to law of sine. Now in order to do that, I'll just go ahead and add this angle. This is going to be at angle B, and this is going to be angle C. So law of sine is simply C over sine C, which is equal to A over sine A, which is equal to B over sine B. So of course this one, just remember it. It's super easy to remember, and I'm not going to go into the proof because it's easy.
Alright, Mr. Mac, hit me with that quiz. Alright, Mr. Mac, hit me with that quiz now. I get it.
Please, Mr. Mac, hit him with the quiz. Please. Just a little circle taught in a Precalc class.
We were given the quizzes once a week.
just a pre-calc class. Learning one little circle. We finally memorized it after 12 weeks.
A circle with 4 quadrants
Of positives and negatives, determined by their position on the axis.
goes round and round and round and round.
Degrees, radians,
All around the unit circle. Don't forget to change your mode. Degrees, radians,
each equivalent
cardinals, found my
and increasing your
time.
Finding cosine and sine.
Because they form 4 triangles.
Doing anything to avoid calculator tests.
Some will pass, some will fail. Some just can't comprehend.
A circle of info that doesn't end.
Goes round and round and round and round.
Some are 30, 60, 90. Others are 45, 45, 90. This determined by the sine and cosine. It can be radical.
3, 1, or 2 over 2. Memorize
that everyday
class.
Don't stop studying. Hold on to that 100.
Unit circle.
Don't stop studying. Hold on to that 100.
Unit circle.
Don't stop studying. Hold on to that 100.
Unit
We're going to use for the purpose of continuity. It only exists in the no holes or breaks are present. Of course, this is very dependent on what the x value is. For example, a limit can be phrased as spending the limit of a certain function as x approaches a certain value. Again, a function must be continuous in order for it to have a limit. We also have various types of limits. For example, the value of the limit can change depending on whether the limit is being approached from the positive or negative side. In addition, some limits may be dependent on the unit circle. For example, if the function is the radian measure is, you can use in that circle to give you the value you need. However, if the question asks you to find tangent x by using the limit as x approaches pi over 4, then you can use the coordinates of pi over 4 to solve for tangent, which is sine or for cosine. To make it a limit is to prove whether or not a polynomial continues. Of course, this does not mean that a polynomial does not continuous continues cannot exist. Means the function not exist at values. They all are closely related to asymptotes. An asymptote is produced when the function begins to approach negative or pi over infinity. And vertical asymptote is created when the function reaches a set value and begins to approach all negatively. This is due to the fact that the function is not defined at this certain value. Horizontal asymptotes are very similar, but they deal with undefined values at the x-axis. you can use three simple rules that will allow you to add limits. Whenever a polynomial being divided by another polynomial, we must observe the leading coefficient that corresponds to the highest x value of the segment. If the exponents are the same, you can simply use the ratio of the function to limit. If the exponent for the top function is greater than the exponent for the bottom function, the limit will work. If the bottom exponent is larger than the function, the totality will not have a limit. If no limit exists. This is not proven through the simple rules of division. Limits are used for the purpose of continuity. If the limit exists, it means that no holes or breaks are present. Of course, this is very dependent on what the x value is. For example, the limit can be phrased as finding the limit of a certain function as x approaches a certain value. Again, a function must be continuous in order for it to have a limit. There are also various types of limits. For example, the value of the limit can change depending on where the limit is being approached from the positive or negative side. In addition, some limits may be dependent on a unit circle. For example, if the function is not the radian that it is, you can use the unit circle to give you the values you need. However, if the equation asks you to find tangent x by using the limit of x approaches pi over 4, then you can use the coordinate of pi over 4 to solve the tangent, which is sine over cosine. Okay, the measure of some limits is to prove whether or not the polynomial can use. Of course, this does not mean that polynomial is not. The unit circle. The circle is a very intricate circle with a radius of 1. It contains 3 quadrants. The circle itself contains radians that range from 0 to 2 pi. For example, radians are separated by an angle negative have a radian of pi over 6. Radians that are separated by angles of 45 degrees are divisible by the fraction pi over 4. The measurement of any radian can be found by dividing its arc length by the radius. The angle of each radian ranges from 0 to 360. This does not mean that these values are set in stone. This is due to the fact that coterminals exist. Coterminals are found by adding or subtracting 2 pi. Similarly, coterminals for angles are found by adding or subtracting 360 degrees. Another entry is that every single radian forms a right triangle. They are created when you trace the x point of the line created from the origin to the x and y coordinates, and you draw a straight and all the way to the x-axis. In experimental tests, we discovered that these lines, mentioned in the previous sentence, that as you move from 0 degrees, we saw the lines were becoming, but as they move from 90 to 100 degrees, we noticed that they increase in size. They also is from 180 to 270 degrees. It decreased from 270 to 360 degrees. We realized that this actually made a graph, that the amplitude of the unit circle was its radius. Therefore, once the lines arrived at 1, they had to decrease, and once it got to negative 1, they had to increase. This also led us to uncover the fact that the unit circle is related to trigonometry. Certain similar lines, as you decrease, the x-axis, they realized a graph that was exactly to the one that cosine makes. For instance, at 90 degrees, or y-axis, we also made a graph that looked like the line. This allowed us to get the ends of coordinates x with cosine thumb. We also realized that we could discover the length of the hypotenuse by using a tangent. Under it became apparent that the values of x and y were 1/2, radical 2 divided by 2, and radical 3 divided by 2. The positions on each circle determine whether they were positive or negative. The integral plays a pivotal role when it comes to converting rectangular forms. The usual directive of triangles on the equal, and x in our case is the cosine side. Once you do this, you are able to find the radius of the triangle by using tangent. Once you have all of these values, you can use the polar equation, radius times cosine times sine. The circle is used anywhere that requires a speedy answer. Due to the fact that it has limited patterns that allow students to remember it and mix it, it is especially if they require training. The unit circle. This circle is a very intricate circle with a radius of 1. It contains 3 quadrants. The circle itself contains radians that range from 0 to 2 pi. For example, the radians are separated by an angle negative at a radian of 1 pi over 6. The radians that are separated by angles of 45 degrees are divisible by the fraction pi over 4. The measurement of any radian can be found by dividing its arc length by the radius. The angle of each radian ranges from 0 to 360. This does not mean that these values are set in stone. This is due to the fact that coterminals exist. Coterminals are found by adding or subtracting 2 pi. Similarly, coterminals for angles are found by adding or subtracting 360 degrees. Another entry is that every single radian forms a right triangle. They are created when you trace the end point of the line created from the origin to the x and y coordinates, and you draw a straight and all the way to the x-axis. In experimental tests, we discovered that these lines, mentioned in the previous sentence, pattern, as you move from 0 degrees, we saw the lines were becoming, but as they were 90 to 100 degrees, we noticed that they decreased in size. The answer is from 180 to 270 degrees. They decreased from 270 to 360 degrees. We realized that this actually made a graph, and that the amplitude of the unit circle